Hello everybody. We're going to jump right into trigonometry here with chapter 4, section 1. So 4.1, we're just talking about radian and degree measure. Now radians and degrees are just two different ways to measure angles. An angle can be measured in radians or degrees. A lot like temperature can be measured in Fahrenheit or Celsius. But before we get to that, let's get some basic information about angles and how we're going to draw them. Let's just see get some labels right. So an angle in standard position has got a couple of properties. For one thing, it has what is called the initial side. And that side, from the initial side, can swing around to make an angle like this is making an angle right there. And we can make an angle from here. I'm just going to use that as a straight edge, no particular reason. And this angle swings around in that direction, opens up till it gets to a terminal side. We're going to label this angle that's created, this angle with those two sides, that's an angle. We're going to label it with this symbol here, and that is theta. So let me just write that down. That is theta. And that's just an angle. It's just a variable, all right? That's a variable. Just like x. It's just a variable. But when you see theta, you know we're talking about angles. So angle theta is just a common way to say angle. So instead of saying x or y or z, we say theta because that's what we call angles, right? Now, it's in standard position. It's in standard position when initial side is on positive x-axis. All right, there's the x-axis, here's the y-axis. When the initial side is laying down flat on the positive x-axis, that is standard position, and almost all the angles we deal with are going to be in standard position. Now, as far as positive and negative goes, this is the direction that it can swing. All right, so we just drew an angle here. I'm going to draw a same angle. This would be positive. That is a positive angle. For example, maybe, let's see, if it went all the way up, that would be 90 degrees. That angle there, let's say it's, 70 degrees. So maybe that's positive, like, for example, 70 degrees. But if it opened the other way, that's positive. If starting at this initial side again and went this way, going down, our theta is negative. That's in a negative direction, going down, and maybe that's like negative, 50 degrees, negative 50 degrees. Just roughly, I don't have a protractor on me to measure it, so that's pretty rough. Okay, now let's talk about coterminal angles. Well, we already talked about these terminal sides. They start with the initial side, and they go to this terminal side. Coterminal angles are simply two angles that share a terminal side. And there could be all kinds of them that share a terminal side, all right? So maybe you have something like, oh, here's an angle here, and it's going to swing around. You don't always put this arrow there. It's just showing you how it's opening up in this case. All right. There's angle, well, we'll call it angle A. Doesn't always have to be theta. It's common, but it doesn't always have to be. And then I got another angle here. And I'll swing around that way till there. And this is angle B. And I think I'm going to estimate the size of these angles, okay? Angle A is about, let's see, that's 90, maybe plus another 45 degrees, right? There's 90 degrees straight up, right angle. And then a little bit further, maybe that's about, 135 degrees. Just roughly. And angle B here, its coterminal angle, well, let's see, it went around 90, then another 80, and then a little bit more there, maybe another 45 degrees, say. So 180 plus 45 is 225 degrees. But it's negative because it went in a negative direction. So these angles up here, I was just estimating them in degrees. You should be familiar with measuring angles in degrees, a 30-degree angle, a 60-degree, a 45, 90, etc. 180 degrees, which is, a straight line. But there's another way to measure angles, and it's far, far more common in calculus and in trigonometry, and that's radians. And let's see where a radian comes from. So I'm going to draw another angle here. This time, notice I got a circle. We're going to be drawing lots of angles on circles because radians, they come from radius, which is a circle. Circles and triangles and angles in circles are going to be a big deal. So here's an angle, okay? Get that going a little further. There's its initial side. And let's say, got this. Open it up to, about there, okay? So there is our angle. Draw this angle too, I think. There we go, it's terminal side. There's that angle, all right? So it opened up. Now, so this here, going around the circle, is the radius. Okay, got this radius of the circle, and two of them here are making that angle. But let's say that I take that radius with my paper clip and I bend it a little bit. So the radius, if I take that radius and the length of that radius and wrap it around the circle, the distance from here to here is 1 radian, all right? This we're going to call, this distance I'm going to call S. And this angle in here is angle theta. And in this case, this angle theta here is 1 radian. I could keep wrapping this around again, and I can get there. Let's see if I can get a good angle there. There we go. And then here, and this angle would be 2 radians. If I did it again to here, so here's 1 radian, 2 radians, and right here 3 radians. It doesn't go quite all the way across. I got a little bit more to get to this exactly straight line. 3 radians is not 180 degrees. It's not perfect. 1 radian, 2 radian, 3 radians. A little bit more, and that would be, to this point, pi radians. Pi is 3.14. 1, 2, 3, and a little bit more pi radians right there. That's what we break this circle down into, units of pi. From here, going back to there, this is halfway. Pi over 2. We're starting here at 0 radians, pi over 2 radians, and all the way to pi radians. Radians is just, all radians is how long that radius is. If I wrap it around the circle, 1, 2, 3. I could keep going all the way around. Down here is 3 pi over 2, and all the way around is 2 pi. Actually, I'm going to write it here. 2 pi underneath, and I'll put 0. 0 and 2 pi, same place. They're coterminal angles. A 0 radian angle and a 2 pi radian angle are coterminal. That's where the circumference of a circle comes from, right? Circumference equals 2 pi r times the radius. That's how you get the circumference of a circle. All the way around a circle is 2 pi. Let's make sure we have our quadrants down. Now then, here is the circle broken down in 1, 2, 3, 4 quadrants. Going around our axis, we're starting here at 0. Up here we said is pi over 2 radians. All the way around is pi radians. Right? 1 radian would be about here. I'm not going to draw it in. 2 radians about there. 3 radians about there. Pi radians. Let's see. Down here, 4 radians. Well, 4 is bigger than pi, so 4 radians would be in here. Down here is 3 pi over 2, and then back to 2 pi. So this is quadrant 1. And in quadrant 1, all my angle thetas are greater than 0 radians and less than pi over 2 radians. They're all between there and there. Over here is quadrant 2. And all my angle thetas that lie in quadrant 2 are greater than pi over 2 radians and less than pi radians. Pi over 2 may say, so it'll be bigger than 90 degrees, less than 180 degrees, but I want to think in radians here. Here's quadrant 3 as we go around. And in quadrant 3, all my angle thetas are greater than pi, but less than 3 pi over 2. And finally, in quadrant 4, I get to use Roman numerals. Not that you have to, but all our angles theta are greater than 3 pi over 2, but less than 2 pi. So there's the quadrants. That's going to come up. What quadrant is this angle in? What quadrant is that angle in? You'll know by the measurements. All right, how do you find a coterminal angle? Let's say that we've got an angle that is, let's see, there's going to be more than one. So let's say we've got an angle that is, I don't know, okay, pi over 4. All right, let's see, where would that be? Pi over 4. Well, since pi over 2 is up here, and 0 is there, and pi over 4 is halfway between pi over 4, a fourth of a pi is half of a pi, going to be right there. This is pi over 4. Well, what I can do is a couple different things. Let's say I want a positive coterminal angle. I'm going to take that pi over 4, and since we already said that all the way around a circle is 2 pi, and that brings you right back where we started from, right? We started at 0, go all the way around the circle, and we're right where we started from at 2 pi. If I go from this pi over 4 side and all the way around, I'll get a coterminal angle. Pi over 4 plus 2 pi, well, need common denominator. 2 pi is the same as 8 pi over 4, right? So pi over 4 plus 8 pi over 4, right? 8 divided by 4 is 2. So all I did was rewrite 2 pi to have a common denominator, and I end up with 9 pi over 4. So pi over 4, and if I went all the way around, 9 pi over 4 is coterminal. But I could also go in the negative direction. And I could take this pi over 4 and subtract from it 2 pi. Pi over 4 minus 2 pi, which is pi over 4 minus 8 pi over 4. 1 pi minus 8 pi is negative 7 pi over 4. Getting a little messy over here, but if I start at this terminal side, the initial side here, and go all the way around, negative 7 pi over 4. It's a little messy, but pi over 4, 9 pi over 4, negative 7 pi over 4 are all coterminal angles. So we're going to end with complementary and supplementary angles and a quick definition of these. Now, a complementary angle, you may recall from geometry, that a complementary angles are angles that add up to 90 degrees, but we're dealing with radians here. So complementary means that if angles A and B have a sum of pi over 2, they are complementary. Supplementary if angles A and B have a sum of pi, they are supplementary. So let's take a look at a couple, and I want to do is find both, I don't feel like writing the words again, find both for pi over 3 And how about 2 pi over 3. So let's see. So find both for those two. Now, I'm not adding these two together here. I want pi over 3, 2 pi over 3. Let's see what we want to do. Okay. So I'm going to find the complement of pi over 3. That means, so find both, meaning find the complement. So, should have wrote that. That's what I'm trying to do. Find the complement for pi over 3. Pi over 3, which means pi over 3 plus what angle theta is going to equal pi over 2. Let's see. That means that theta equals pi over 2 minus pi over 3. Well, let me get a common denominator here. So I'm doing fractions. Lowest common denominator is going to be 6. So this would be 3 pi over 6 minus 2 pi over 6 equals pi over 6. That's the complement. All right, there's the complement. The supplement means they're going to add up. That means that pi over 3 plus theta will equal pi to find its supplement. All right, so theta equals pi minus pi over 3. Well, let's get a common denominator here. Pi, I can rewrite pi as 3 pi over 3 minus pi over 3 equals 3 pi over 3 minus 1 pi over 3 equals 2 pi over 3. Which makes sense. Pi over 3 plus 2 pi over 3 is pi. Let's take a look at this 2 pi over 3. I'll find its complement first. 2 pi over 3 plus some angle equals pi over 2. Therefore, that angle I'm looking for equals pi over 2 minus 2 pi over 3. Let's see. Let's get this together here. I'm going to make pi over 2 common denominator, right? So I want this to be 6. I'm going to multiply by 3. So I got 3 pi over 6 minus 4 pi over 6 equals negative pi over 6. All right, I get negative. Complementary, supplementary angles. The thing about them is they must be positive. We're adding together two positive angles to get the complement, to get the supplement. I get a negative. 2 pi over 3 plus negative pi over 6. That's what pi over 2 is. Well, that means that 2 pi over 3 has no complement. There's no angle I can add, no positive angle I can add to this that's going to give me pi over 2. Let's try the supplement. 2 pi over 3 plus some angle theta equals pi. Subtract 2 pi over 3 from both sides. Theta equals pi minus 2 pi over 3. Rewrite this to get a common denominator of 3. Right? Pi is the same as 3 pi over 3. Subtract, and I get pi over 3. Oh, well, I got that before, too. So it has a supplement. 2 pi over 3 has a supplement, but has no complement. And pi over 3 has both a complement and a supplement. Big words, a lot of material. Take a look at the homework.